All right, so these are the area formulas that you guys need to know. Um, you should have most of them committed to memory already, but if you don't, make sure that you make it a point to do so. We're going to use them all year. So area of a rectangle, you guys are used to seeing length times width, but we're going to stick with area equals base times height. That's what you'll hear us say a lot. Same thing. Area of a triangle is 1/2 base times height. Don't forget that 1/2. That's the biggest mistake people make. Area of a trapezoid. Remember, a trapezoid is a figure that looks similar to this. Sorry, that's just going to be a sketch. Your area formula there is 1/2, and then the sum of the bases, so base 1 plus base 2 times the height. Area of a parallelogram. Well, a parallelogram and rectangle are essentially the same shape, so they have the same formula, base times height. And perimeter of a polygon. Perimeter, we're talking about what's going on the sides around. So you are just going to take the sum of all the sides, however many there are, whether there's 3 or 12 or whatever. Okay. Volume of a cube. So when you're talking about area, you're talking about 2 dimensions, length and width, base and height, whatever. When you're talking about volume, now you're adding in the 3rd dimension. So volume of a cube, you guys, a lot of people have heard volume as length times width times height, but we're talking about a cube. So since it's a cube, that means all of the sides are the same. So we're going to say it's side times side times side, or side cubed. And then the Pythagorean theorem, you know from the first video and from your previous classes, that's a squared plus b squared equals c squared. And remember that c is always your hypotenuse, which is always your longest side. Okay, so that's from the last video. Those are the formulas that you want to write somewhere, commit to memory, etc., because that's what we're going to be using. I'll use them today in this video, and we'll use them throughout this unit as well as the upcoming units. So this is a review for Math 1. We're going to talk about terms and like terms and combining like terms a lot when we do adding and subtracting and multiplying polynomials. So terms, remember, we're just talking about something like 4 or 5x or 7x squared, okay? It's a number, a variable, or a product, so multiplying 5 times x, a number and a variable. Biggest thing you want to remember is that they are separated by addition and subtraction. Okay. And then like terms means that they have the same variable with the same power. So something like 3x squared and 7x squared are like terms. Or something like, I don't know, 4x and negative 12x. Anytime they have the same variable with the same exponent, so x, x squared, x cubed, whatever, those are like terms. So monomial, binomial, trinomial, you guys have heard those before. Monomial means you just have one term in your polynomial. Binomial means you have 2 terms. So something like 4x plus 7, okay? Trinomial obviously means 3 terms. Hopefully you're catching on to that. So something like x squared minus 5x plus 13. So x squared is a term, negative 5x is a term, and 13 is a term. And then a polynomial is just 4 or more terms. Once you hit 4, it's just called a polynomial. So whether it has 4 terms or 12, it's a polynomial. Okay. So these first 4, these are review. You just want to remember to watch your signs when you do these. So for number 1, we want to find the sum. So remember that means we're adding. When you're adding, you really just want to look out for any coefficients in front that we need to distribute or really negative. So in this case, when we take away the parentheses, 4 plus 3x is going to stay as 4 plus 3x, and then plus 2 plus x. Nothing changes because you're positive the whole way through. At this point, you just need to combine like terms. So 4 and 2 are your constants, and then you have 3x and x, which are your other set of like terms. Always answer these in standard form, meaning you're going to go from highest exponent to lowest. You should always end with your constants if you have any. So in this case, 3x and x gives me 4x, and 4 plus 2 gives me 6. So that would be your simplified answer. For number 2, you're doing the same thing. However, when you look at number 2, now you have this 6 in front. So remember from last year, you need to distribute that 6 in. So this first set of parentheses isn't going to change, and you have 7x squared minus x plus 15. But then you're going to have plus 6x plus 12 when you distribute in the 6 to the x plus 2. Now when you go to look for like terms, this is the only x squared term. You have an x term here and an x term here, and then a constant and a constant. I'm a visual person, which is why you see me do, the underlines, the squiggles, the circles. You don't have to do that. It's totally up to you. So again, we want it in standard form, so start with your highest exponent. So 7x squared. Negative 1x plus 6x is a positive 5x. And then 15 plus 12 is 27. So that is your final answer there. For number 3, now we're subtracting. So this is where you need to watch out because you have this negative. So essentially kind of like we distributed the 6 in the last problem. Now you want to think of it as you're distributing the negative. So you have x to the 5th plus 8, but then this is going to become negative 3x to the 5th and negative 5x. So that negative out front changes every sign inside that set of parentheses. So we have an x to the 5th and a negative 3x to the 5th. Since they're both x to the 5th, those are like terms. And then 8 is the only constant, and this is the only x term. So you're going to end up with a trinomial because you have 3 different types of terms. X to the 5th minus 3x to the 5th is negative 2x to the 5th. And then the x is on its own, so it doesn't change, as does the 8. For number 4, same thing. We're going to distribute the negative. We just have a little bit more to do. So you get negative x squared minus 3. This is positive for our next set, so nothing in that second set of parentheses changes. So you just have plus 10x squared plus 8x minus 13. But then here you want to distribute that negative 2, so you end up with negative 28 plus 2x. Now when we go to look at like terms here, we have an x squared here and an x squared here. We have a constant here, here, and here, and then our x term and our x term. So we end up with negative 1x squared plus 10x squared is 9x squared. My x's, I have 8 here and 2 here, so 10 total, so plus 10x. And then negative 3 minus 13 minus 28, if you combined all those, you get negative 44. And that's your simplified answer there. So that's just straight addition and subtraction when you're combining polynomials. Now, an application of that, the first one we're going to do is perimeter. So remember, perimeter is where you find the sum of all of your sides. So here, finding the perimeter of this triangle, we have 3 sides. So our 3 sides are 5x plus 12, 10x, and 25. So we have 5x plus 12 plus 10x plus 25. So in this case, we're adding all the way across. So when you drop your parentheses, nothing's going to change. We end up with 5x and 10x, and then 12 and 25. So your final answer is 15x plus 37. Now, you need to put context to this because it started out as a contextual problem. So this is 15x plus 37. Put parentheses around that, and it's perimeter, so it's inches. Okay, remember, a distance, like perimeter, is inches, area is always squared, and volume is always cubed. Okay. For the next one, if you remember from Math 1, these tick marks mean all these sides are congruent, which means they're all the same. So if I'm asking for the perimeter of the figure, that means this side is 7x to the 4th plus 8x to the 3rd minus 2. Well, so is this side, so is this side, and so is this side. You could write that 4 times and add them all together. But knowing that you have 4 of them that are the exact same, the faster way of doing that is saying I have 4 sides that are 7x to the 4th plus 8x to the 3rd minus 2. And then you can rely on your distribution from last year, distribute that 4 in, and you end up with 28x to the 4th plus 32x to the 3rd minus 8. Again, we need to give it some context. That, in this case, is feet, and that's your final answer. Okay. So when I'm asking for perimeter, all I'm asking is that you add up all the sides and then don't forget to give it some sort of context, inches, feet, etc. Now, that's adding, subtracting, all that. But the one thing we haven't done is multiplying. So you guys have talked about in Math 1 and even before that in like your 8th grade class or 7th grade class, as well as the video last week, which was a review of exponents, exponential rules. So now, this isn't in your notes, but you might want to write them down somewhere. We're just going to take the distribution property from last year, and instead of doing it once, like example number 1, we're going to do it multiple times in the same problem. So you guys are used to a problem like number 1. If you distribute that 4 in, 4 times x is 4x, 4 times 7 is 28. Okay, so there's no context to that problem. That is your answer. However, when you look down at something like number 2, now you're doing the exact same thing. It's like you want to pretend that this x isn't there, and let's just focus on the 3. And treat it like number 1. So you're going to distribute the 3 to the x and the 3 to the negative 7. Well, if you were to do that and your problem was just 3 times x minus 7, you would end up with 3x minus 21. You guys have all done that before. However, you can't ignore this altogether. It is there. So now you're going to do the exact same thing with the x times x, and x times negative 7. So it's almost like doing the distribution twice, or double distribution is what you'll hear us say. So now you want to rely on those rules of exponents. The biggest one you want to remember from the video is when you have like a to the m times a to the n. That ends up as a to the m plus n. So what you'll hear us say is when you multiply, you add your exponents as long as your bases are the same. So in this case, x times x for this first set of distribution for the purple, this is really x to the first and x to the first. So when you multiply x to the first times x to the first, you add your exponents and you get x to the second, and that's positive. So it's plus x squared. And then x times negative 7 is negative 7x. So as long as you can focus on this property, you'll be okay here. Now the last thing we need to do is just combine our like terms. We have an x here and an x here. This is a constant, and then our only x squared. So again, do it in standard form. We have x squared. 3x minus 7x is negative 4x, and then minus 21. And that trinomial is your answer. So I'm just going to practice that twice more and do the exact same thing I just did. So I'm going to start with the x, and I always start with the parenthesis on the left. You don't have to, but it's like reading a book, left to right. So you're going to take this x, you're going to distribute it here and here. Again, x times x, it's similar to the last problem. That's x to the first and x to the first. When you multiply, you add your exponents. X to the first times x to the first would be x to the second. X times 5 is a positive 5x. Then you repeat the process with the second term in your binomial. Negative 6 times x is negative 6x, and negative 6 times 5 is negative 30. So now we need to combine like terms. Our only two like terms there are the 5x and the negative 6x. We end up with x squared minus 1x, so minus x minus 30. Okay. And then the last one, same process. We're going to start with the x, distribute it to the x squared and to the 8. So now this is an x squared. Well, x times x squared, again, we're focusing on that exponential property. This is x to the first. X to the first times x to the second, you add your exponents and get x to the third. X times 8 is a positive 8x. Come back, do the same thing with the negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times 8 is negative 24. In this case, you don't have any like terms, so you can't combine anything, but we do want it in standard form. So x to the third minus 3x squared plus 8x minus 24. So you start with your highest exponent and continue on down until you hit your constant. So now we're going to take that and the adding and subtracting and do some other work with some application problems. So number 7 is similar to the PBT that you guys started the year with. So it says find the missing side length of the rectangle if its perimeter is 8x squared minus 16x plus 16. So if it's a rectangle, if this side is 3x squared minus 5x plus 7, so is this side. These are the same, and then these are the same. We don't know what those two other sides are. So I do know I have 2 of the 3x squared minus 5x plus 7 sides, but then I have 2 of something else. I don't know what that something else is. But if I have 2 of one side and 2 of the other, and I add all those sides together, that's perimeter, which should be 8x squared minus 16x plus 16. So now we just need to try and get this underlined. I don't give it another variable. That confuses me. You definitely don't want to give it an x because we already have an x. I usually just leave it like a blank. So distribute here, and we end up with 6x squared minus 10x plus 14 plus 2 times something equals 8x squared minus 16x plus 16. So if I'm trying to get this by itself, so eventually I can divide by 2, I'm going to get rid of my 6x squared to the other side. I'm going to add my 10x to the other side. And I'm going to get rid of my 14 to the other side. So now I'm left with 2 times something, because everything else canceled out, equals 2x squared. Negative 16 plus 10 is negative 6x, and 16 minus 14 is positive 2. Now we're going to divide everything by 2, and it's everything, not just whatever you feel like it. So that missing side that we're looking for is going to be 2 over 2, which is 1, so x squared. Negative 6 over 2 is negative 3x, and 2 over 2 is a positive 1. So that missing side is x squared minus 3x plus 1, and it's in context, so that's feet, and that would be your final answer. All right, for number 8, this is asking for the volume of a cube. So remember we talked about in the front, volume is s cubed, because they're all the same. So if one side is x plus 8, they're all x plus 8. So volume in this case is going to be x minus, I'm sorry I said plus, x minus 8 cubed. You guys, the most common mistake is that people say that that's now x cubed minus 8 cubed. What this really means is that there's 3 of them, and we talked about that with the warm-up with like a 3 cubed is really 3 times 3 times 3. This is really x minus 8 times x minus 8 times x minus 8. So we're going to do a lot of multiplying here. I'm going to focus on these two first. Oops, sorry. Okay. So those two, if you were to multiply them together, so think about what we just did here. These two, I'm going to start with my x, and I'm going to distribute it here and here. Well, x times x is x squared. X times negative 8 is negative 8x. Then I'm going to move to the negative 8. Negative 8 times x is negative 8x. Negative 8 times negative 8 is a positive 64. Combine like terms there, and you end up with x squared minus 16x plus 64. But that's just that yellow box. We still have that x minus 8. So now we're going to multiply one more time. I'm going to shrink this up so I have a little bit more space. Okay, and I'm going to do the same process again. I'm going to start with the x squared, and I'm going to distribute it to the x and to the 8. X squared times x gets me x to the third when you add your 2 and then that 1 right there. And then x squared times negative 8 is negative 8x squared. Then I'm going to move to the negative 16x. Negative 16x times x is negative 16x squared. Negative 16x times negative 8 is a positive, because you have a negative times a negative, 128x. Last but not least, we're going to do the 64. 64 times x is a positive 64x. And 64 times negative 8, don't forget that's going to become negative, is going to get you a negative 512. So it's a lot of multiplying, but now we've officially multiplied all of our parentheses. So we did the first two in this step right here. cleaned it up, and then brought down this guy to right here and multiplied again. So our volume, when we combine like terms, is x to the third. These are nice because they all lined up. Negative 8 minus 16 is negative 24x squared. 128 plus 64 is 192x. And then minus 512. Let's give it some context. It's millimeters, and in this case it's volume, so it's millimeters cubed. That would be your final answer. Okay. All right, for the next one, this is the area of a trapezoid. So we're going to have area equals 1/2 base 1 plus base 2 times the height. And now we just need to figure out what each of those are. All right, so the 1/2 obviously stays as a 1/2. Now, your base 1 and your base 2 and your trapezoids, we have a base right here. Oh my God, you guys. Just kidding. This isn't a trapezoid. I'm getting way ahead of myself. Sorry. Okay, let's try this again. For all of you for the past 2 minutes that have been wondering what I'm doing, this is a parallelogram. Oh my God, sorry. Okay, there we go. This is a parallelogram, which makes our lives a lot easier. Wow. All right, area here is base times height. So your base, notice in this picture you have 3 separate dimensions that you're given. Well, in this case, this 2x squared plus 1 doesn't matter because your base is the bottom of it. In this case, it's the top. They're the same. The height is similar to a triangle. It's whatever makes that right angle with the ground. So this is going to be my base, and this is going to be my height. So I have my area is going to be 4x squared plus 2x plus 5. And then my height is x to the third minus 10. All right, so we have a little bit of work to do here. We're going to be multiplying a lot. That's okay. Let's start with that 4x squared and distribute it here and here. All right, well, 4x squared times x to the third. You're just going to multiply your coefficients, which in this case is just a 1. So 4 times 1 is your 4. X squared times x to the third, you add your exponent, so x to the fifth. And then 4x squared times negative 10 is a negative 40, because 4 times negative 10 is negative 40, and then the x squared. Then we're going to go to the 2x and distribute it the same way. 2x times x to the third is a positive 2x to the fourth, because you have x here and x to the third here, so when you add your exponents, the 1 plus 3 is 4. 2x times negative 10 is negative 20x. And then last but not least, we have the 5. 5 times x to the third is a positive 5x to the third. And 5 times negative 10 is negative 50. So your area here, when we combine like terms, there's only 1x to the fifth, so 4x to the fifth. There's only 1x to the fourth, so plus 2x to the fourth. And then there's only 1x to the third. There's actually only one of everything. Sorry, as I'm looking at this, I'm realizing that. So plus 5x to the third minus 40x squared minus 20x minus 50. So your area is that whole polynomial, and then its area and its inches squared. Make sure to give it some context. Okay. You could multiply backwards there and start with the x to the third and distribute it 3 times. That's fine too. It really doesn't matter. All right, for the last one, it says use the figure to answer the following questions. So we want to find the area of the figure. So that's a triangle. Sure of it this time. So since it's a triangle, we're going to use our 1/2 base times height formula. So our base is down here. Our height is up here. So area is 1/2 times my base, which is 2x squared minus 9x, times my height, which is x squared. So I'm going to take care of my parentheses first before I take care of the 1/2. So my area is going to be 1/2. And in this case, I am going to multiply backwards because I just have a monomial here to a binomial. So it doesn't matter. You get the same answer either way. X squared times 2x squared is 2x to the 4th, because 2 plus 2 is 4. And then x squared times negative 9x is a negative 9x to the 3rd. Then the last thing you need to do is take care of that 1/2 and distribute that in. So your area here, 1/2 times 2 is just 1, so that ends up being x to the 4th. 1/2 times 9 is 4.5, so negative 4.5 x to the 3rd. And in this case, that's going to be miles squared because it's area. Now this is find the length of the hypotenuse. Well, remember, this is a right triangle. To find sides of right triangles, it's a squared plus b squared equals c squared. So a and b are your legs, c is your hypotenuse. That's what we're looking for. So it doesn't matter which one you use. Let's say we have 2x squared minus 9x for a, plus x squared squared for b. So I made a my 2x squared minus 9x and b my x squared. So now here, this ends up being 2x squared minus 9x times 2x squared minus 9x when you expand that out. And then this is a power to a power. So in this case, power to a power you multiply. So 2 times 2 is 4. So plus x to the 4th equals c squared. And remember, you guys were trying to solve for c. That's what we're looking for. Okay. So when you do that, let's start with the 2x squared and distribute that in. 2x squared times 2x squared is going to get me 4x to the 4th. 2x squared times negative 9x is negative 18 from the 2 times negative 9. And then x squared times x is x to the 3rd. And then negative 9x distributed in. Negative 9x times 2x to the 3rd is negative 18x to the 3rd. And negative 9x times negative 9x is a positive 81x squared. And then we still have the plus x to the 4th from before equals c squared, and we are trying to solve for c. So let's combine like terms here. We have an x to the 4th and an x to the 4th, an x to the 3rd and an x to the 3rd, and then our x squared. So we're going to end up with 5x to the 4th minus 36x to the 3rd plus 81x squared, and that's c squared. Well, the only way to get rid of that squared is to square root it. So your answer is c equals the square root of 5x to the 4th minus 36x to the 3rd plus 81x. And in this case, that's miles. And that's just a distance because it's a sign. Okay. So that's how you multiply or add, subtract, multiply, and then we took that multiplication and applied it here with volume, area, and more area, and including our hypotenuse question. Okay, so if you have questions, please come find us.